Hello friends. In this tutorial we are going to learn about applications of stack. In the previous tutorial we already learned about what is a stack. In stack what operations we are going to perform is pushing and popping. But how this stack is used in the real world systems? How we use? What are the applications of stack? First one is used in compiler constructions. Stack is used in compiler constructions, that is in scheduling the time, and stack is used to convert the expressions, convert one expression to another expression, one to another expression. And stack is used to evaluate these expressions. We are going to learn what are these expressions, how the conversions goes on, and it is used in Tower of Hanoi problem and is used in rat in a maze and jumbling of words, all these things, jumbling of words or letters and so on. These all are used, these all are the applications of stacks. So what are these expressions? What is a plus b? A plus b is one expression, right? We have three kinds of expression. One is infix, other is prefix, and other is postfix. What is this infix? A is operand, B is operand, plus is operator. If this plus or any plus or minus or whatever it might be, multiplication and all those things are operators. If these operators are present in between any two operands, then it is infix operation. If the operator is present before the operands, for example plus AB, it is present before the operands, it is prefix. Postfix is present after the operands, it is known as postfix. So how do we convert these expressions? We can convert infix expression into prefix and infix expression into postfix, but we can't convert prefix expression into infix and postfix expression into infix. Only we can convert infix to prefix as well as postfix, that's it. How do you convert this? For example, now conversion from infix expression to postfix. Let's take an example, a plus b minus c into d by e. We know the operator's precedence. First is into, next division, next minus, next plus. So how do we go? Operator's precedence first can be, these two are in the same precedence, into and this division. So how do we do? A plus b minus c into this d by e, as converting into postfix it will be after operands. So de by, let's take it in a bracket, let's consider it as 1. And now next precedence will take as into a plus b minus c, as we are considering this as complete 1, we get like this, c d slash, consider it as 1, and this into will go here. Now consider this as 1, as next precedent is minus, a plus b, minus should be here, right? So c d e slash into minus. Now we consider this as 1, this plus should go here as we consider this as whole 1. So a b c d e slash into minus plus In this way we can convert infix expression into postfix. Now the same expression, how can we convert into prefix? A plus B minus C into D by E. Prefix A plus B minus C into D by E. It should be here. It's D by E. By is in between this. We have to put this here. D E slash. We consider this as 1. Now this next precedent is into. Now A plus B minus C. This into should go here into C. This whole we consider D E. Now this we consider this as 1. Now A plus minus B, this minus will come here, so B star C slash D E. Now we consider this as 1. Now this plus should come here, so plus A minus, A plus B minus B, okay, plus A minus B into C slash D E. This is the final expression converted into prefix. Now let's take a big example and try, so that you will get to know. Let's take A plus B plus C plus D into E plus F plus G into H. Let's convert it into postfix expression. Postfix means next to the operands. So before the into and slash, the main preference will give to the braces. So first we'll convert this braces. So A plus BC plus, we have to take this braces first. So BC plus D star, this E plus F, EF plus, take like this. Next GH star, take it as 1. Now according to precedence, into is the first one. It is D, it is in between this and this. So what we do, A plus BC plus postfix is, so DEF plus star plus GH star. Now all are pluses, so let's consider from left. A plus BC plus DEF plus star, this GH star, this plus here. So now we consider this as 1, and this plus is in between these two operands. A plus BC plus DEF plus star GH star plus, and this plus here. Now this is one operand, this is one operand, in between is plus. So how we do, ABC plus DEF plus star GH star plus plus, and this plus here. In this way we can convert this into postfix expression. In this way, conversion of expression takes place from infix to postfix and prefix. Now, evaluation of expressions. How to evaluate expressions? Let's take an example like A plus B minus C into D. This is an infix expression. Convert into postfix and evaluate it. How do we do? Postfix, that is after the operands. So A plus B minus, as star takes the first precedence, CD star. Next minus takes the precedence, so A plus B C D star minus. Now A B C D star minus plus. This is one which we converted into postfix. Now as this is the application of stack, how do you evaluate it? First we do with push from left to right. So pushing A into the stack. Before that, let's take the value. As evaluating the expression means we need to have values for A, B, C, D. Let's take A equal to 4, B equal to 5, C equal to 2, D equal to 1. So A of 4 we pushed. What is the output of it? Nothing, because there is no operator in between like plus or minus and no other operand, so there is no output for this. Next is B. We have to push B. So A of 4 and B of 5. And next again push C. A of 4, B of 5, C of 2. And next push D. A of 1, B of 5, C of 2, D of 1. Now we take into. If we take, the first one is CD. So what we do? A of 1, B of 5, C into D. 2 into 1 is 2. Output is 2 here. And next minus. Minus in between 5 and 2. So A of 1, 5 minus 2 is 3. So output is 3 over here. And now let's take plus. A of 1 and 3 are there. So 1 plus 3 is 4. Output is 4. In this way we can evaluate the expressions by converting it into postfix and evaluating. In the same way we can convert into prefix and evaluate it. As I already told you how to convert it into prefix here. Conversion into postfix and conversion into prefix. And if you give values to it, push this, push according to the order given, order we evaluated, converted from left to right. Push all these things, and when operators come in between, we have to do the operations for that. In this way we can evaluate the expressions. Now let's evaluate prefix expression also. Let's take an expression like A plus B minus C into D slash E. This arrow is nothing but square root, like 2 square equal 4 kind of thing. So precedence square, braces square into slash minus and plus. So how do you evaluate? We convert into prefix expression. Is prefix means before the operands. So A plus B minus C into D slash, as this should come in before this, arrow E F. Take it as 1. Now this and this, in between we have slash. So A plus B minus C into This slash comes before D arrow E F. This we consider as 1. Now see, this is one operand, in between star is operator. So A plus B minus star before that C slash D arrow E F. Now the expression looks like this. In between minus is there. So A plus minus coming before B star C slash D arrow E F. It looks like this, and plus is in between, so plus A minus B star C slash D arrow E F. Now let's take value as A equal to 1, B equal to 2, C equal to 3, D equal to 4, E equal to F, F equal to 6. How to evaluate these expressions? First, we need to push F. For postfix expression, we push from left to right, but for prefix expression, we push from right to left. So pushing F, that is F of 6. Now pushing E, F of 6, E of 5. Now next we have arrow. Arrow means here we have F and this first one 6 power 5. Arrow, I said it is power, so this 6 power 5. 6 power 5 value is 7776. And next is D. Push D and output right here, and push D. 7776 D of 4. And next push slash, that is division. So 776 by 4, we get 4 ones are 4, again 17, 4 fours are, okay, let's use calculator. It is 1994. 776 by 4 is 1994. Value is 1994. So push C. C of 3. Now after that we have to push multiplication. It is 1994 into 3. Five eight three two. Output is 5832. Now push P. 5832 and B of 2. And next push minus. 5832 minus 2 is 5830. And now push A. 5830 A of 1. Now push plus, that is 5831. Output is 5831. In this way we can convert the expression into prefix and evaluate the expression in this way. We can convert expression from infix to postfix and infix to prefix, but we cannot convert the postfix and prefix expression into infix expression. And While evaluating for postfix expression, we evaluate from left to right. For prefix expression, we evaluate from right to left. And precedence is first braces, next power, next star and division, next minus, next plus. In this way, we can convert and evaluate the expressions. And one more application of stack is rat in a maze. And this is one of the application of stack. This problem can be solved by using backtracking method. Backtracking, for example, have 1 2 3, we can choose only one, that is from 1 we can choose either 2 or 3. First we go to 2, evaluate it, next again we go back, that is nothing but backtracking, and again we go to 3. This is forward. Moving forward is forward, moving back is backtracking, going back and tracking it again. It uses backtracking concept. We solve this rat in a maze using backtracking concept. So first step what we do is we consider a matrix which is of n cross n, that is okay, n cross n matrix, you know, like square matrix, like 4 cross 4, 3 cross 3, that is rows and columns must be equal. So rat, let's consider 2 boxes. Okay, 1 2 3, 1 2 3. So this is 3 cross 3 matrix, right? If rat enters here, this is the source, and rat should leave here, this is the destination. Rat starts from the source and reaches the destination. It starts from top left and goes to bottom right. This is the top left and this is the bottom right. And while taking a matrix, we consider 1 0 0 0 1 1 0 0 1. This is source, this is destination. This 0 we consider as dead end. That is, if you have a wall over here, we want to go like this, this is the dead end, we can't go this way. We have to choose the alternate way, or else we have to go back, that is nothing but backtracking. So in this way, this 0 are dead ends, we close these blocks like this, these zeros. Only we can enter in this way. Let's consider this, we can go like this only. And the function to solve this maze problem is, let's take a name of the maze as solving the maze, right? So maze of maze, okay, let's take it as solve maze, maze comma x comma y comma solution, that is x y solution, solve. Here maze represents blocked and unblocked blocks in the maze. This is blocked and these are unblocked. That it represents 1 as unblocked, 0 as blocked. This maze is used to represent that. And x and y are the rat position where it is being. If it is here, it is stored in the 0, 1 location. So the whole, and the solution is nothing but the path of the rat. And this, as this solve maze is a function to find the path of the rat to reach the destination. If this function, what we say, if this function finds the path to get out of this destination, then it returns true. If the function doesn't find the path for the rat, then it returns false. So let's take an example to understand this rat in a maze problem. For example, let's consider a matrix 1 1 0 0 0 1 0 0 0 1 1 1 or 1 1 1 in this way. This is 4 cross 4 matrix. Four cross 4 matrix. So how it looks like? 4 cross 4 matrix, right? So it looks like this. This is source. This is destination. And as zeros are represented as blocked, we shade this so that we can better understand that these are blocked one. This is blocked. So rat can move only in this space. So let's take this function. Let's take solve maze of 4 4. This maze represents blocked and unblocked blocks in a maze. I said right. So how many blocked and unblocked are there? 4 cross 4. So 4 4. And now rat is at the position of here. So 0 comma 0. And solve. It returns true if there is a path. Again solve maze 4 4. Rat moves here, that is 0 comma 1 0 1 solve. There is a path, so it returns true. And now solve maze 4 4 0 comma 2 is the next one as it moves left to right. And solve. It returns false as there is no path over here. Next. So it goes down. Maze 4 4. It goes down to 1 comma 1. Solve true. It goes to 1 comma 2. It returns false. So again it comes down, that is 2 comma 1. 2 comma 1 returns true. And 2 comma 2 returns true. And again 2 comma 3 returns true. Now if it comes down, 3 comma 3 returns true. And the rat reached the destination. This is the rat in a maze problem. In this way we can solve the rat in a maze problem using stack pushing. How the stack application is used over here is pushing inside, pushing. If it doesn't go here, it comes back, popping out. Again pushing out of the destination to reach the goal. In this way, rat in a maze problems, Tower of Hanoi problems are solved. Tower of Hanoi problem, we will have 3 things and sizes of rings. They are placed in such a way that the highest, that is the largest one, will be placed in the bottom, and all this should be transferred onto the second one, but only one at a time. And this small one should not be under the big one. So first we will push this here, next we'll push this here. No, wait. Okay, in some way. First we will push one here, next again we will push one more here. Okay. First we will push this one here, again this one we will push here, and again this small one we kept here, right? This one we will push on here. So now this one we can push to here, this one, and the small one will push again here. I'll show you. Tower of Hanoi problem. Let's take 1, 2, 3. Big, small, small. These three things should be placed in such a way that again the small one here, this here, this here. Only one at a time we can push. We can push one at a time. And this small one should not be under the big one. So we should push in such a way that it should be arranged in this same way. So first we will push this small one in the second one like this. Again this one we will push here. Again next step we will push the small one here. Now this big one we will push here. Again this small one we will push on to the first one. Now again this one we will push here. Now the small one we will put here. In this way, Tower of Hanoi problem, by pushing here, again popping out from here, pushing, popping, in this way stack application is used in the Tower of Hanoi problem. So in this example, in this tutorial we have learnt about applications of stacks like evaluation of expression, what we say, conversion of expression from infix to postfix and prefix, and evaluation of expression for infix to postfix is left to right, infix to prefix is right to left. In this way we converted. And next is rat in a maze problem, pushing and game winning of the game, and this is Tower of Hanoi problem. So in the next tutorial we are going to learn about queues. If you like this video, please do like, comment, share and subscribe, and click on the bell icon so that you will get the notifications of the new uploads. Thank you.